Great. So in this session, we're going to take a deep dive into GraphQL, and we'll sort of look at Fullstack GraphQL. By the way, the slides are available online, bit.ly/AustinGraphQL. I'm sure they'll also be shared with everyone at the conference too. So my name's Will. I'm a software developer at Neo4j. Has anyone used Neo4j before? I'm familiar. Okay, a few folks. Okay, so Neo4j is a graph database. We'll talk about that a little bit. So I work on a team that builds integrations with Neo4j and other technologies. So I work on our GraphQL integration. I work on a data visualization integration. A big part of my job is just helping build tooling that helps developers build applications with Neo4j and graph databases. So today, like I said, we want to do sort of a deep dive into full stack GraphQL. So we'll take an overview of GraphQL. We'll look at how do we build GraphQL APIs, how do we build GraphQL services. Then we'll take a look at some database integrations for GraphQL. We'll talk about deploying GraphQL services. We'll talk about querying GraphQL. We'll specifically look at a React integration for querying GraphQL. Then we'll take a look at GraphQL authorization and some of the ways to do that. So like I said, full stack GraphQL is kind of the focus. These are some of the tools we're going to be using: GraphQL, React, Apollo, and Neo4j Database. So first, just a little bit about Neo4j to sort of set the context, since we'll use Neo4j as our data layer for GraphQL. So Neo4j is a graph database. It's a database management system that uses a property graph data model. So in a graph, nodes are the entities, relationships connect them. So we're talking about graphs as the data model rather than tables or documents with other databases. Neo4j uses a query language called Cypher. You can think of this as like SQL, but for GraphQL. There's an example in the top right of the screen there of what Cypher looks like. It's very much about pattern matching. So some use cases for graph databases and Neo4j, things like if we're building personalized recommendations, if we're interested in network and IT management, representing our dependencies of our services as a graph, identity and access management, lots of different use cases for graphs. And once you start to think in terms of graphs, you sort of start to see graphs everywhere. Okay, so that's just a little bit about Neo4j to sort of set the context for what we're going to use for our data layer. But again, we're going to be talking full stack GraphQL with React, GraphQL, Apollo, and Neo4j Database. Think of this as what we like to call it as the grand stack. So first of all, what is GraphQL? So GraphQL at its heart is really a specification for an API query language. How many people have used GraphQL? A little familiar with GraphQL? Okay, a few folks. So with GraphQL, we start with type definitions that defines the schema, the data that's available, what fields are available on those types, and how they're connected. That becomes the sort of specification for our API with GraphQL. And then the client can basically use that schema to construct queries and only ask for the data that the client is interested in, and the results for that query will match the fields that the client is asking for, right? So GraphQL makes this observation that your application data is a graph. Regardless of how you're storing that on the back end, for the consumer of your API, we're presenting them with a graph. So if we're talking about users that are placing orders that contain products, those products fulfilled by vendors, right? All of this data is connected, and that's a graph, and the consumers of our API, our clients, should think of it as a graph. So that's an important sort of fundamental thing to think about when we think of GraphQL. So let's take a look at an example. Let's say we have some data about movies, genres, directors, actors, this kind of thing. Well, the first thing we do when building a GraphQL API is start with our type definitions. So, okay, we have a movie type, we have a type genre, actor, director, and we can specify all of the fields that are available on these types and how they're connected. So a movie is connected to 0 or more genres through this genres field. This is using what's called the schema definition language. It's this sort of language agnostic way of defining GraphQL types. One thing that's really neat about GraphQL is we can use this feature called introspection. So we can essentially query a GraphQL service for the schema. What are the types? What are the fields available? How are these types connected? What are the entry points for the API? And there's some really nice tooling, Graphical and GraphQL Playground. This is a screenshot of GraphQL Playground that allows us to sort of treat this type definition that we get through introspection as sort of documentation for our API. So we can see what are the entry points, what's all the data that's available. So this is a really nice sort of self-documenting feature of GraphQL. Okay, so now we're ready to query our GraphQL API. And here's a query on the left. Let's zoom in on that a little bit. So the different components of a GraphQL query, well, we're specifying the operation name, the entry point, and the arguments. So here we're starting at the movie query field, which is the entry point for our API. And we're passing in some arguments. In this case, for title, I want the movie A River Runs Through It. And then the rest of our query is called the selection set. So here we're specifying, okay, starting at this movie that we're going to find. First of all, what fields on movie are we going to return? Well, we'll take the title. And then, okay, well, movie type is connected to actors. So, okay, for actors, I want to find the first 2. And on the actor type, well, just give me the name. And then we continue on. So you can see here that we're really expressing in our query how to traverse this graph of movies, genres, directors, and actors. And our query is specifying exactly which pieces to return from this traversal. So the data comes back to us in this JSON format. And we can see here that we're getting just exactly the fields that we're asking for in our query. Cool, so that's kind of an overview of GraphQL. Let's make a couple of observations here. So first of all, remember that GraphQL is an API query language, not a database query language. So this means that there's limited expressivity for things like projections, aggregations, variable length path queries, this kind of thing that you might find in database query languages. And it's also important to remember that GraphQL is data layer agnostic. So regardless of how we're storing our data, we can put a GraphQL API on top of that. So while we're making this observation that GraphQL is exposing your data as a graph, we don't need to actually use a graph database to store that. And oftentimes with a GraphQL API, we end up fetching data from multiple sources and composing that together into one unified API. So what are some advantages of GraphQL? Well, one is addressing this issue of overfetching. So with GraphQL, we can specify exactly the fields that are relevant for the client. So let's say if we're rendering a view of, I don't know, maybe a summary of blog posts, and we're only showing like a short description and the title field. Well, when we're fetching data from our API, we don't need to grab the full text of the blog, all of the images, all of this. No, we just need to grab like a description and title field. So this is solving the problem of overfetching. It means that we're basically sending less data over the wire. The other is this problem of underfetching. So let's say that we're rendering our lists of blog posts and their authors, and we fetch our list of blog posts, but we don't have the author information to show alongside that? Well, then we need to make a request again to sort of hydrate each one of our author objects to be able to show that in the view. Well, with GraphQL, we can specify, no, I need the blog post title and the author name that goes along with that. So solving the problem of underfetching here, this means that to render a view for application or for whatever we're fetching the data for, that means we can just make one round trip to the API. Another advantage of GraphQL is that there is a specification that says this is how we do things, this is what GraphQL is. With REST, we don't really have a specification, and there are sort of several ways to do REST. With GraphQL, it sort of comes with specification included. And another benefit is this idea of relationships versus resources. So the way that I often interact with APIs in general is in the context of relationships, right? So blog posts and their authors, orders and the products contained in them, right? And what's nice about GraphQL is that that is sort of the context that I'm modeling and thinking of my data, so that allows me to express those connections sort of as a part of GraphQL. Like I mentioned earlier, GraphQL can also be useful for unifying disparate systems, microservices. It's very easy to combine data from these multiple services and expose them via one GraphQL API. And also GraphQL can really simplify data fetching if we think of data fetching in terms of components. And when we get to sort of looking at querying GraphQL, we'll see how we can basically bind GraphQL queries to components of our application. So those are some advantages. What are some challenges of adopting GraphQL? Well, one main observation is that a lot of these really well understood practices from REST don't really translate or apply in the GraphQL world. So for example, HTTP status codes, well, that doesn't really apply with GraphQL because everything, even if it errors out, is going to give us a 200 OK. So error handling is a bit different. This means things like web caching doesn't quite work the same way. Another complication is, okay, well, if we're allowing the client to construct some arbitrarily complex query, does that mean that we're exposing arbitrary complexity to the client? How do we deal with performance considerations there? Another problem that we see is this N+1 query problem. So going back to our example of blog posts and authors, if I fetch a list of blog posts, well, then do I need to go back to the database to grab the author for each one of those, right? That's the N+1 query problem. We'll see an example of this and how we can get around that in a minute. And then the final one, this I kind of hinted at earlier, this idea of query costing and rate limiting. Because the client can construct arbitrarily complex queries, how do I deal with rate limiting? How do I sort of limit the depth, the complexity that the client can query? Now, there are sort of solutions and best practices in the GraphQL world that address many of these issues. And some of them you could argue are maybe kind of non-issues. So caching, for example, well, most GraphQL API requests are done on an authenticated API, so maybe caching doesn't really apply there. This issue of exposing arbitrary complexity to the client, well, we can sort of lock down the queries that a client can request and basically just give them the ID for a query and say, here's your list of queries to choose from. And this N+1 query problem, the GraphQL engines integrations that we look at in a minute address this issue. So there certainly are ways that we can address these challenges. Okay, let's look at an example API and sort of see how we build it. So this is a service that my team built for our Neo4j community site. Let's zoom in a bit here. So this is a discourse forum for Neo4j. And if we look on here, we see some activity feeds for community content, community projects, new certified developers. And all of this content above the fold here, this is being loaded from a GraphQL API. And if we go in and look at the network request, we can see we're just doing a fetch request. Let's take a look at the actual GraphQL API that we're querying. So this is GraphQL Playground. This is like a sort of query workbench for GraphQL. And this is the API that our Neo4j community site is hitting. So we can inspect the schema here, and the first thing we'll see are the entry points for our API. So you can see, okay, we have 4 entry points here. We can search for the top open source projects, the top community blogs, the top developers, and so on. And we can see here, okay, this is going to return an object of type community open source project. It's connected to an author that's a discourse user. We can see the fields that are available. That's nice. And here's a query that is finding, okay, the first 10 top community open source projects, title, URL, the author, and their discourse avatar. So this is the information that we're pulling back to render this view on the Neo4j community site. Okay, so that's cool. Let's see how we build that. There's a blog post that I wrote that talks about how this actually works, but the basic idea is we have a Neo4j instance running that is collecting data about the Neo4j community from things like the Stack Overflow API, the GitHub API, Meetup API. So anytime someone in the community writes a blog post about Neo4j or publishes a Neo4j related project to GitHub, Community Graph finds out about it and stores that in the database. And we have a public version of this that anyone can query. It's kind of interesting. If we were querying it directly in the database, it would look something like this. So find, a GitHub user that created a repository. Here we're looking at, these are some of my Neo4j related repositories that Community Graph picked up on. So if we're querying the database, it looks something like that. But of course, we're building this web application. We can't just expose, any arbitrary database queries. So we want to build a GraphQL API on top of this. How do we do that? Well, we start with our GraphQL schema that defines our types. So here we have blogs and the users that are the author of the blogs. Those are our type definitions. And then we have a special type in GraphQL called the query type that is defining the entry points. So every field on the every field on the query type is an entry point for the API. Here we're interested in exposing the top community blogs and content. So we'll add that as a field on the query type. Now these type definitions, these are just a string. Here we're building a Node.js app that's going to serve this GraphQL endpoint. Now the next step after we define our type definitions is to build our resolvers. So resolvers are functions that have the logic for how to fetch the data for our GraphQL request. And they look like this. So here's sort of the skeleton resolver for our top community blogs and content query field. And inside the resolver, we do things like maybe make sure that this is an authenticated request, query the database with a database query or with an ORM, validate that the format that we get back is in the right format. Maybe we get this, massage the result a little bit into the format we're expecting to return. These are the kind of things we would do in a resolver. In this case, we're going to query a Neo4j database. Here's the Cypher query that we use. This is implementing a exponential time decay function that a lot of these rating sites like Hacker News and Reddit use, so that new things that get voted up pop up early and then slowly kind of drop off the activity feed. So here's our full resolver. It's not too important what's going on there in the details. Just know that we're querying a database and we're sort of massaging the results as they come back, handling an error if it occurs. But basically, this is what is fetching the data for finding the top blogs for the activity feed. Okay, so that's our schema and resolver for our GraphQL API. How do we actually serve this thing? Well, there's some tooling called Apollo server that makes it really easy to serve an executable, a GraphQL executable schema, so type definitions plus resolvers using Node.js. It's built on top of Express. So basically all we do is pull in Apollo server. We combine our type definitions and resolvers to make an executable schema. We create a database connection, and then we spin up Apollo server. Okay, and we saw what that looked like, and that's running live. So this is sort of the standard way of building a GraphQL API, and we can see some sort of common problems. Some of this we talked about earlier. So things like schema duplication. Okay, I have a schema for my database and for my GraphQL service. There's possibly a lot of mapping, translation, boilerplate code there in the resolvers. And then I still haven't really solved this n+1 query problem. If I'm getting a list of blog posts, then I have to hit the database again for each one of those posts to give me the author for all of those. So this is where GraphQL engines come in. Engines is, I don't know, maybe not the best term, but these are sort of database integrations for making it easier to work with GraphQL. So there are several of these integrations out there, things like Prisma, AWS AppSync, Hasura, PostGraphFile, and the Neo4j GraphQL integration. Hasura and PostGraphFile work with Postgres. AWS AppSync is a service for exposing AWS resources through GraphQL. And then Prisma is a more generic tool for working with multiple databases in GraphQL. So let's take a little closer look at the Neo4j GraphQL GraphQL engine. So the goal for this is to enable what's called GraphQL first development. So we want to use GraphQL type definitions to drive the database. That should handle database query generation for us. And then we still want this to be extensible. So we want some way to be able to provide some custom logic, in this case, either via Cypher embedded in our GraphQL schema or custom resolvers that we implement. So these are the sort of the principles for this integration. Is we want to be able to define type definitions in GraphQL, and that should drive our database data model. And from this, we should provision a GraphQL service. Any arbitrary GraphQL request, we should be able to generate automatically the database query for that. In this case, it's a Cypher query. And that should be a single query, so just one round trip to the database. And then to make this extensible with custom logic, we allow for what's called a schema directive in Cypher. So we can basically annotate fields that then become computed fields that map to a Cypher query. There's a few different flavors of this Neo4j GraphQL integration. I work on the JavaScript version of this, so this is for building Node.js APIs. There's also a Java JVM version of this and a database plugin as well. So, okay, this is roughly what this looks like. We have some service that's running using Express, Apollo server, and this Neo4j GraphQL JS integration that's taking in GraphQL requests, generating database queries, going out to the database to fetch the data, sending that back to the client, right? That's the general idea. Let's take a look at an example here. So this code, this comes from a project called the Grand Stack Starter. So we start off here with a schema, GraphQL type definitions. So we have data about users, businesses, reviews that these users have written, and businesses that are in a category. So that's our GraphQL type definition, and then the code for this is pretty sparse. We're importing a few libraries. We're starting an Express app. We're just passing our type definitions to this make augmented schema function. This comes from our Neo4j GraphQL integration. So what this is doing is taking the type definitions and provisioning a CRUD GraphQL API with all of those operations, as well as adding things like filtering, pagination. We're creating a connection to the database. This is just running locally. And then we're passing this to Apollo server to just start up a GraphQL endpoint. So we'll go ahead and run this. And it says, OK, GraphQL server is ready on localhost 4001/GraphQL. And first of all, if let's zoom in a bit here. If we take a look at the schema, we can see that we have query fields and also these mutations. We haven't talked about mutations yet. Mutations are essentially write operations in GraphQL. So we've basically taken the type definitions and added all of the entry points for all of our CRUD operations that we would expect to be able to do. And here's sort of a more complex query where we're saying, OK, let's find the first 3 users, give me the name of the user, and then let's give them a business recommendation. And we can see here we can add some more fields as well. So let's go from the user to the businesses that they're reviewing. And we can see here, OK, we're getting back some more fields. But what I'm interested in is this recommendation field. So, OK, here we have a user, Will, and we're recommending a business. Let's see what category that is. So for Will, we're recommending Hanabi, which is a ramen restaurant. So how are we coming up with that review field? Well, if we jump back in the code here and take a look at our GraphQL schema, in our type definitions on the type user, we have this recommendation field, and we're using here this Cypher schema directive to bind this field to this Cypher query. And what this Cypher query is saying is it's saying, OK, find a user who wrote a review for a business, what other users are writing reviews for that business, and of those users, OK, what other businesses are they writing reviews of that this user hasn't been to, right? So this is sort of a simple collaborative filtering recommendation query. And so to expose that sort of custom logic in our GraphQL API, we can just sort of annotate our schema with that query, which I think is pretty powerful. If you want to play around with that example, that, like I said, is just the Grand Stack Starter project, which is kind of a seed starter with this data. So to sort of review what we're doing with these GraphQL engine projects, and again, we looked at the Neo4j GraphQL project specifically, but the other projects that I mentioned share similar functionality, right? These are declarative database integrations where we're using GraphQL to drive the database with our type definitions, and we're provisioning GraphQL APIs that are sort of auto-generated from just our type definitions. We're enriching that schema with things like complex filtering and ordering. So this is removing a lot of boilerplate code that we'd be writing for fetching data. And the other important point to point out here is that we're generating a single database query. So this is solving that N+1 query problem that we talked about. Now, you might be wondering, okay, how do these GraphQL engines work? How are they generating these database queries from GraphQL requests? So it might be interesting to take a look at this. So if we look back at the signature for our resolver functions, one of the arguments that's passed into each resolver is this resolve info object. And this resolve info object is really important for these GraphQL integrations because it contains information like the GraphQL query abstract syntax tree, the executable schema object itself, the selection set for the query, any variables that were passed in. So what these GraphQL integrations are doing are taking this resolve info object, inspecting that to build up the database queries. Okay, let's talk a little bit about deploying a GraphQL service. So the example that we looked at, we were building an Express app and a Node.js app. So we can deploy that using platforms as a service like Heroku, Elastic Beanstalk on AWS. We can put that in a Docker container. We can spin up a VPS, right? So those are sort of things that are traditional, we'll say. But we can also use serverless options for deploying our GraphQL API. So these are things like AWS Lambda, Google Cloud Functions, Azure has similar functionality. Is anyone using serverless functions? A few folks, okay. What I think is really interesting are these tools that are built on top of like AWS Lambda or Google Cloud Functions. And so specifically, these are things like ZiteNow or Netlify functions. Anyone use any of these services, ZiteNow or Netlify? A few folks? Okay, so the interesting thing with these are that they give a very different developer experience than what you have on just sort of creating your own Lambda functions and deploying that. So if we take a look here at our application and the different bits that we need to deploy here, okay, well our database, that's going to be hosted on some database service like Neo4j Cloud or on AWS somewhere. For our GraphQL service, well, we want to use some serverless functionality for that, either AWS Lambda or the Google Cloud Functions. And then our client application, that's just static code that we can serve on a CDN somewhere. And what's nice is if we can combine sort of the ability for deploying our static client code and our serverless API with tools like Netlify that basically have deployment options that we can push to GitHub or something like that, and using GitOps can handle provisioning our Lambdas for us. So this is a good blog post that describes how to do this with Netlify. There's a similar functionality in ZiteNow, which is, if you look at the GrandStack starter project, that's kind of the default deployment option there. So that's one interesting space I think to look at is not just the serverless functions as a service offerings, but some of the tooling that's built on top of those as well. Okay, so let's take a look, since we're talking full stack GraphQL, at some of the client considerations. How do we query GraphQL in the client? And specifically, we'll look at how we do this in React. So we saw the Apollo server integration for helping to construct and serve our GraphQL API. Apollo also has tooling on the client side. So these are exposed to us as front-end framework integrations, typically. And here we're going to use the React integration for Apollo client. Apollo client's not the only client for GraphQL. There are lots of other options, things like Relay and things like Urkel, which is a more slimmed down version. We saw how we can use GraphQL Playground, which is sort of a query workbench. But really, when it comes down to it, we can really use any HTTP client to query a GraphQL API. It just depends on what sort of features that we're interested in along with that. So Apollo client brings, like I said, front-end framework integrations and caching, which is really nice. In that example that I showed from the Neo4j community forum, we're just using basically just a fetch request in JavaScript. Okay, so what does the React integration look like? Well, first we create a new Apollo client instance and point it to our GraphQL endpoint. In this example, this endpoint is not authenticated, so we don't need to worry about bringing in our auth headers or anything like that. Then we can then inject this Apollo client instance into the React component hierarchy. I'm not going to talk too much about React here, but this is similar to how we would use Redux or the React Context API. And then what's nice is in our component, we have now a query component that can take a GraphQL query, or we can also define what's called a fragment, which is basically a well-defined selection set for our GraphQL query and bind that to our React component. So we're compartmentalizing our data fetching code with our React component. And then the children of that are basically defining how to handle the data that comes back. In this case, we're just rendering a table. So fairly simple. Cool, so I have just a few minutes left. I want to talk just a little bit about how we handle authorization in GraphQL, and then we'll open it up for questions and discussion. So how do we do authorization in GraphQL? There are lots of options here, and these range from, okay, we can sort of handle authorization in our resolvers. We can sort of delegate that to a business logic or data access layer, and we're just calling that from within our resolvers. We can wrap our resolvers with something that we might think of as like a GraphQL middleware, or we can use schema directives. So we saw an example of that Cypher schema directive where we're annotating our type definitions. We can basically use schema directives there to define our authorization rules in our type definitions. So if we do authorization in our resolver, well, benefit that's pretty easy to implement for fast prototyping, but this can get pretty ugly pretty quick. We don't have any sort of single source of truth for our authorization rules. We end up with this duplicated logic spread across our resolvers. So then we might implement this data access layer where we actually have sort of one single implementation that specifies how to request data. The problem here is how do we handle this in the context of generated resolvers? So when we're using our GraphQL engine tooling, where that tooling is basically creating our resolver functions for us, how do we use this approach with that is the complication. Another option is wrapping resolvers. So this is a library called GraphQL Shield as the example we're looking at here, where we're defining our permissions all together as sort of rules, and then those permissions are matching in the resolvers, so sort of middleware. And then the final approach is defining in our schema our rules for authorization. Cool, so I am out of time here. I'll just point out in the slides there's more information on how to build these schema directives, both for authorization and then some other considerations for schema directives. And I'll also point out in the slides, if you're interested in more resources, just pointing out some of the other GraphQL implementations and other languages and frameworks, some pointers to some good blog posts and documentation for GraphQL, and things related to Neo4j GraphQL. And if you're interested in getting started with Neo4j, Neo4j Sandbox is a great way to play around with that. We have one specific to GraphQL. Cool. So I think that is all of my time here, but do we have time for questions?